The idea that serotonin is primarily acting in the brain, primarily acting on neurons, primarily to boost your mood and make you happy is total nonsense. And that is basically a marketing campaign that arose because of the SSRIs in the 80s. And the reality is,
Masterjohn.
Thank you for having me. My academic background is I have a PhD in nutritional sciences. I've used that for helping people harness the power of nutrition on their journey towards vibrant health. One of the most interesting things about mitochondrial function is that it declines 1% per year with age. The major driver of aging is that loss of mitochondrial function.
That's fascinating. I remember the first time I took them, the first thing that happened was I was like, I can breathe.
SSRIs are mitochondrial drugs in ways that no one prescribing them understands. Benzodiazepines are mitochondrial drugs in ways that no one prescribing them understands. They'll do it in a way where you're supposed to cycle between stimulation and rest and recovery, and they just put pedal to the metal 24/7, 365.
My dad's been very ill, and I think SSRIs and then his withdrawal was treated with clonazepam that just neurologically injured him. We were worried it was Parkinson's, but it's not Parkinson's, it's like a neurological injury. What do you do? Masterjohn, welcome to my podcast.
Thank you for having me. Appreciate it.
I appreciate how fast you got back to me too. My dad's been very ill, and we've had a lot of chronic health issues in my family, going back to like my great-grandparents. And we've gone down a whole bunch of rabbit holes, and some things have helped a lot, and some things haven't. But I kind of got clued into mitochondrial dysfunction a couple of months ago. I think because what my dad's been sick with has been very difficult to treat and kind of like multifaceted. And it just seems like something fundamental is very wrong. And I came across you, and we just talked about this. I think Mad in America did a podcast with you, and it was transcribed. And I was like, okay, this is extremely interesting. And I hadn't really heard of this in the last 10 years. So I thought we should talk. So before I inundate you with questions, can you give a brief background about who you are and what it is you do?
Sure. Well, my academic background is I have a PhD in nutritional sciences. I've used that for the past couple of decades towards helping people harness the power of nutrition on their journey towards vibrant health. I've come to the realization through the work that I've done over the past couple of decades that the driving force behind all health and disease is the fundamental ability of your mitochondria, which are the powerhouses of your cells, to extract the energy in the food that you eat and convert it into a usable form. That usable form is ATP, to support the fueling of the producing of everything in your body, the maintenance, the repair, the distribution. And as a result of that journey, I now run a mitochondrial testing company called Mitochondrial. And my time is split between learning new things, both from reading the most recent research, but also reanalyzing the research that goes back centuries and everything in between, towards coming up with new strategies that people can use without testing anything, or new strategies that people can use to make our product more useful to the people who are using it.
Okay, that's interesting. So I guess we could start with that. How do you test mitochondrial function?
Well, our interest is not in testing whether it's good or bad so much as it is in testing what can we learn about it that would give you something actionable and also unique. So if we tested everyone who's in this town, and we're telling everyone the same thing, or we're telling half of the people one thing and half of the people something else, not really worth it. But if we can find, each person 1 in 100 type of advice that's unique to them, I think that's worth doing a test for. So we're focused on that. And the reason we can do that is that although the mitochondria has at broad scope the fundamental problem of how to convert your food that you're eating into energy, using, by the way, the oxygen that you breathe to do that, there are specific engines that have specific requirements, and you can break that process down into different things that you can measure. And that has nutritional implications because some of those things run on certain vitamins and some of those things run on others. And if you look at the mitochondrial cocktails and supplements that people are taking, say you're taking CoQ10 has a very specific role in that chain of reactions. And so measuring the performance of those things around there can actually tell you something about whether there's something unique about your needs for CoQ10 and so on.
Cool. Okay. I didn't even know you were able to measure that. So that's very interesting.
Yeah.
Okay. So I think part of what brought me to mitochondrial dysfunction is we had a transformative experience going on an all meat diet. And that was very out there. It's slightly less out there now, but it like completely changed my dad and my mom, and my health, like dramatically. And then slowly research is coming out being like, okay, maybe this is because you're in ketosis. Like who knows what other factors are going on. But at least there's some research being done now. But so that brought me to the nutrition side that completely changed my life. And then I got sick again when I went to Miami, and it was from black mold or just mold in general in my Miami house. And I got a whole bunch of the symptoms that diet had originally fixed back, even though I hadn't changed my diet, and was like, that's odd that it would kind of manifest in the same way as my food reactions. And I guess maybe the underlying factor was they both impact mitochondria. And that's what you say, right? Is that there's a whole bunch of things out there that can negatively impact your mitochondria, and you get this weird array of symptoms because of that?
Yeah, that's absolutely true. So my familiarity with your story is basically what you've talked about on YouTube and what you've written up on your website. And I think it seems like the key turning points are inflammatory disease in your youth, going on Enbrel and methotrexate, developing mental problems the next year, 8 years old, and then going on SSRIs to treat that.
Yeah.
Having diet fix that, then going off the SSRIs, having that lead to its own catastrophe. And that's where you and your father's story kind of share similarity. And then this red meat carbohydrate are big turning points in the mold toxins and the cholestyramine in the treatment, right?
That's exactly it.
When I look at that, I see some common threads that all relate to mitochondrial function. So first of all, in people, so Enbrel is one of numerous, they call them biologics, that are drugs that are effectively blocking the function of an inflammatory mediator called TNF-alpha. And I've seen a pattern where people who go on those generally have a pattern of mitochondrial dysfunction that leads to the buildup of toxic metabolites in the mitochondria from the inability to fully process one of the molecules of food through to the end product to extract the energy out of it. And one of the ways that you fix that is you bring in carnitine. And carnitine is something that you make yourself, but many people have genetic blocks in the ability to make it or to transport it. And when you get in the diet, you know where you get it from?
Meat.
Red meat.
Interesting.
Okay. So carnitine, the signal to bring carnitine in the cell to detoxify those problems in the mitochondria is TNF-alpha and other cytokines. Now I see another problem, or another pattern, I should say. A lot of times, people who have an inflammatory disorder that responds to a TNF blocking biologic then develop mental health problems while they're on the TNF blocking biologic. And I think the reason is that the TNF is there for a purpose, and it's a double-edged sword. But the purpose is your mitochondria don't have enough carnitine. And by the way, if you were eating a red meat diet, they'd have more carnitine because you'd be supplying it, right? But the demand to get carnitine into the cell, especially when you don't have a good supply, is to make TNF-alpha and other inflammatory cytokines that bring the carnitine into the cell, right? So if you now go on now that TNF-alpha drives the inflammatory disorder. It's going to interact with other genes, and it's going to cause arthritis, or it's going to cause psoriasis, or it's going to cause Crohn's disease, or whatever it is. And you're seeing that as the problem, but you're not seeing the problem it was fixing. So then you go on the biologic, and now the other problem is there. So you stopped the crazy catastrophic inflammation, but now you've made aspects of mitochondrial function worse in a way that your brain does not have the energy to control mental health. And your brain starts slipping on the control of certain weaknesses, and those start to arise as that. And then you get to SSRIs, which is a whole nother catastrophic problem to talk about.
That's fascinating. Okay. I mean, that totally makes sense.
Now, let me add one more thing. So I noticed a few years ago when I had gotten sick and I had a cough that wouldn't go away for like 2 months. And I said to myself, I'm not sick anymore, but I still have a cough. I must not be resolving the inflammation. So I went and did a lot of research, went down rabbit holes on what causes T cells, which are inflammatory cells involved in the inflammatory response, to not go from the activated pro-inflammatory state to the clean up this mess and resolve it state.
Yeah.
And T cells in their active inflammatory state run for fuel on carbohydrate and glutamine. And you can't really control how much glutamine is in your system without causing other problems, but you can certainly control the amount of carbohydrate. So this lion diet to me is you're taking away the carbohydrate that's for some other reason, the T cells just won't stop activating, right? You take away the carbohydrate, they calm down. You go on this very carnitine rich diet. The only way you can get meaningful amounts of carnitine with diet alone is to mostly eat red meat. And now you're solving this problem that's going way back into childhood.
Oh, wow.
Which is to stop this inflammatory demand for the carnitine by just easing up on it by supplying it.
You starting your own college?
Yeah, well, it's well started.
The progressives hope for universal education at something approximating zero cost. That's what we've got.
We can bring you the best lectures that you'll be able to get anywhere
In terms of their quality of content and also the production values.
All the people we're bringing on board are existential philosophers in some real sense. We think that a humanities education should enrich your experience in every direction and be nothing but positive. Well, except also difficult and challenging, but that's also positive.
Yeah, we surely didn't have that when I was a kid.
I've gone down rabbit holes about like ketogenic diet didn't work for me. It wasn't good enough. I was still having inflammatory responses. So I was like, okay, it can't just be ketosis that's like helping me right now. It's the elimination of everything else that's a contributing factor. And I've had so many different theories about like what that is, whether it's leaky gut and I'm reacting to plant proteins that shouldn't be in my blood, like something as simple as that. And then recently, so it's been over 10 years since I stopped taking SSRIs, which was, I think those were so detrimental to my health compared to everything else that I was on, compared to the mold exposure, compared to everything. That I think maybe is part of the reason I'm still not really able to eat other things. But I started reintroducing other things and my reactions are much less, but I still feel best just eating meat, which seems like something's still up. And then the other thing, and this has hit my dad really hard, and I think SSRIs and then his withdrawal was treated with clonazepam that just neurologically injured him.
Which has its own mitochondrial thread.
Yeah, I want to get into that too, the difference between SSRIs and benzodiazepines. But we have an extremely difficult time with most supplements, especially vitamins. So generally you go to a doctor, and even if it's a very good integrative doctor, they'll be like, okay, well, make sure you're getting certain B vitamins and certain supplements, like you talked about CoQ10, right? And we haven't really found any that don't cause like excess energy agitation. And then when I started looking into mitochondrial dysfunction, I was like, does that mean, is that a symptom too? Like an inability to tolerate things that should be helpful?
Yes. And I think there are a lot of idiosyncratic reasons why one person might not tolerate specific supplements and another person might tolerate others. But it sounds like you don't tolerate any, which is interesting.
I can take folinic acid.
Yeah.
Took me like 8, but no
Well-
other form of B vitamin really at all.
Yeah, I mean, I think your specific tolerance for folinic acid, I think, is probably a result of a secondary layer of sulfur toxicity, and I think
Yes.
that
I
could explain
have
like
that.
glutathione
It is-
intolerance and yeah.
And do you think that's from eating so much meat? Because that happened
the hot
long
the
time
red
ago.
meat so the red meat carbohydrate restricted background, although it has plenty of benefits like we were just talking about, there are trade-offs, and one of those trade-offs is you have a very high intake of sulfur amino acids, you have a very low intake of carbohydrate. Your body's going to make carbohydrate one way or another, and one of the ways to do that is to break down sulfur amino acids and make carbohydrate. So you're right there, you're predisposed to breaking down sulfur amino acids. Sulfur amino acids are very interwoven with the methylation process where these B vitamins come in. Like folinic acid is the form of folate that's not related to methylation. Methylfolate is the form that is related to methylation.
And that stuff murders me.
When you have more methylation than you need, you break down the fundamental building block amino acids, which are sulfur amino acids. So, you add, it's like pouring fuel on the fire. If you're going to add methylfolate to a diet that's high in red meat and low in carbohydrate, because now you've got two reasons to be breaking down those sulfur amino acids. And when you get too much broken down sulfur, you wind up having mitochondrial toxicity, but you also have independent neurotoxicity going on as well, and just neuroexcitation. So I think you described a feeling of agitation, or what do you mean by that? Restlessness?
Yeah.
Can't sleep?
It's always, if it's really bad, it's like severe insomnia for a couple of days. So this happened. I was trying to test out different forms of B9. So I did methylfolate, and then I did folic acid, which I know people are moving away from, but this was before I could get my hands on like folinic acid properly. But it seems to be almost every B vitamin. Maybe B1 is less bad, but it's restless legs, and I would say restless legs is the worst part, and insomnia. And with Dad, it's even worse. But then my mom, who's been on this diet almost the same length as me, is totally fine, has like none of that. So we're in like, my family's in this position where the diet helps, can't really move it, but there's obviously something going on, and we couldn't figure it out if it's
Does your mom
methylation, damage.
share-
She was never on any psych meds.
Yeah. So it seems like you got some genes from your dad that are
Not
common
ideal.
threads between it just seems like your dad and you share
Yeah, like a lot.
aspects of your story that you don't with your mom. So
Yeah. I think that was from, we were both on SSRIs for like a decade.
yeah.
So I feel like some of it's that.
but you were both on SSRIs for a reason, right?
Oh yeah,
Yeah.
for severe crippling mental illness.
Right.
Yes, it wasn't just for fun.
So I'm saying, like, yes, it's
Yeah,
true
yeah.
that you and your dad share health history because you both went on SSRIs.
Yeah.
But you also both went on SSRIs because
For
you
the
share
same
health
reason.
history, right?
Yeah.
So anyway, I think it's possible that there are many explanations, and it's possible that there's one. If I were to try to make this all fit into one explanation, I would say that these different B vitamins are all playing various roles in methylation and sulfur metabolism. Those two things intersect. When your sulfur metabolism is messed up, you're going to have more insomnia, you're going to have more anxiety, you're going to have more restlessness, restless legs. I think that's the simple explanation, is these are interacting with those two systems in a way that's aggravating sulfur catabolism. And I think even though the red meat, low carb diet is helping you a lot in many ways, it's kind of a baseline predisposition to having those problems. And so I think that's the best explanation for that. And I do think that, a lot of people who are intolerant to supplements could work within the diet to try to boost those nutrients up at a much lighter level, because you might benefit from more of them, but you might not need hundreds of milligrams.
I was thinking it might be a dosing problem. Dad pointed out the B vitamin intolerance before he was even on SSRIs. So this was like maybe 10 years before the diet. He just said, I can't take B vitamins, but that was about as deep we got into it. So
Yeah.
maybe that's methylation issues or mitochondrial something.
Yep.
Okay, well, that's cool because that's kind of where my research has brought me to, was something's up with the sulfur part. Anyway, what do people do if they're stuck in a position where they're extremely sensitized to things or chronically ill and they're having a hard time treating themselves and they think maybe it could be mitochondrial dysfunction? Like, how do you just start tapping into that treatment for that?
Yeah, well, I think there are different people have different amount of resources, and so there's different things that you can try on your own, and there's you can achieve faster results with testing. But I think that for sure, like people who are supplement intolerant should just get out of the framework of like, I need to take this supplement, and should work on trying to look at their diet and analyze their micronutrients and gently lift up those nutrients through the diet, because supplements are, a lot of people don't have any problem with taking 10 times or 100 times what they need, but some people do. And the fact that you negatively reacted to 200 milligrams doesn't mean you don't need 2 more milligrams of a B vitamin in your diet. So I think that can be very helpful. The reason that I developed the mitochondrial testing product is because it can help shed a lot of light on stuff like this. I had one, and the worst part about it is there are these trends out there where people get really good results from megadosing something, and then even clinicians pick it up as like, they read the anecdotes, they hear the stories, and that becomes a treatment for that thing. And so, one example is high dose thiamine, vitamin B1. And there's a lot of people who get miraculous results from taking 2,000 milligrams a day, even though we're all getting like 1.3 milligrams a day in their diet. So that's, light years between those two things. And one of the people who used our mitochondrial test had a problem with fatigue. And that was her only problem at the time, was her fatigue was 10 out of 10. So it was a problem, but she didn't have any other problems at that time, right? So her practitioner puts her on high dose thiamine, about 1,000 milligrams a day. And the fatigue does start getting better, but then she develops some kind of neuromuscular problem where she couldn't walk straight and she couldn't keep her balance. And she stayed on the thiamine for months while this was happening and getting worse before she realized she had to get off of it. And when we ran the mitochondrial testing on it, it basically said like, look, you have some blocks here. And if you just dump energy down that pathway, you're going to run into some trouble. And so she might have needed thiamine, but because that just unleashed energy in one pathway, dumping on something else that was blocked, that really caused a lot of mitochondrial stress for her. And cutting out the thiamine was very helpful. Gently raising the other B vitamins with foods that had all of them very slowly over time was very helpful. And the last piece of the puzzle for her was physical therapy to, like, I think, even though nutrition is incredibly powerful in causing health or disease, if you've got a neuromuscular condition, you also need specific exercises to address that. Proper nutrition gives your body the power to respond to those exercises, but those exercises are what actually restore your balance or your neuromuscular function. And so I think that, testing can be extremely valuable when it comes to trying to address those things that are unique between people.
That's
but a general rule is, if you don't react well to megadosing, stop megadosing.
Yeah. For sure. Okay, interesting. So what do you recommend for natural ways to increase your overall level of B vitamins?
The two big dietary factors are organ meats and nutritional yeast. Now, nutritional yeast on the market has a lot of B vitamins added to it, usually. There are a couple of brands out there that are unfortified. I only use unfortified nutritional yeast because why would I take, like, I don't eat fortified foods, because then I'm not getting my nutrients from food. Like, the whole point of improving the quality of your foods is to get food nutrients, not supplements, right?
Yeah.
So unfortified nutritional yeast, I think, is a great source of B vitamins. It doesn't have all of them. Liver as an organ meat is like through the roof in almost all the B vitamins. So if I had to pick one of those, I'd do liver.
Okay.
But
I have
yeah.
a question on this. So one of the things I haven't strictly avoided, I'll have liver sometimes. But at the beginning of this like meat journey and trying to get healthier, I couldn't handle liver.
Yeah.
Was that a B vitamin issue? Because I was like, any part of the cow seems okay, but liver is like something doesn't make me feel good.
In your case, I think it's a B vitamin issue, but but liver is, if you're going to overdose on anything from liver, B vitamins, vitamin A, and copper are kind of the things that it's really, really high in. And so anyone with a problem in any of those things kind of have a problem with liver. In your case, it just makes sense to pin it on the B vitamins because you've also tried the isolated supplements, and the fact that you tolerate folinic acid, not methylfolate, gives a very super specific, like it makes it overall not sound meaningless. Like I just, every time I take something, I get sick. The fact that you have really specific, like I tolerate this form of folate and not that one, I think adds a lot of scientific plausibility to the idea that you've got B vitamin things going on. So for you, I would pin it on B vitamins.
Well, maybe it's a dosing problem too, and I need to start with like one liver capsule. Instead of having like a bunch of liver. That's for
sure true. And, that person that I was talking about definitely had some like, even with the foods, had some dosing things. And I think that was, I don't think it usually gets that far until you mess some other things up.
Yeah.
but yeah.
Okay. That's interesting. Well, I think we need to do this test. We did like earlier this year. We've been in touch with so many doctors for my dad this year. And we ran a bunch of genetic screening because we're like, how much of this is this weird B vitamin problem? But he can't take any B vitamins without skyrocketing symptoms to like someone that looks like they should be in the hospital, right? With a little bit of a B vitamin. It's like, okay, what do we do there? So we did sequencing.com, I think, and looked at the genome and ran through some like third-party sites. And there were some methylation problems here and some like COMT problems but we haven't done that test. That sounds maybe necessary at this point.
Yeah. Well, we'll arrange that. Okay, and cool. I think that could allow the sequencing to shed a lot more light than it has as well, because if you find specific things wrong in the mitochondria, they might have a genetic basis. And those whole genome sequencing reports are like, even if you are an expert, you really can't just go inside the file and find what's important without having a structured way of digging for it.
I mean, thank goodness for AI. That's made it a lot easier, but it's still a lot of data. Yeah. Okay. Interesting. Well, then let's go back to, can we touch on SSRIs and benzodiazepines a bit?
Sure.
Because it concerns me because like a lot of dad's symptoms, honestly, they look like previous neurological damage that we kind of thought was resolved that's flared up for no reason. Like there was no medication trigger. He's very careful with his health other than doing a lot of work. But other than that, he's very careful. And it's like, why did all these symptoms come back? And I've been talking to people who were on SSRIs or benzodiazepines being like, yeah, sometimes symptoms can come back from this like original neurological injury. So do you have any information on like, why do some people get such severe, they call it protracted withdrawal or something like that, but why do some people get so sick when they stop these medications and some people don't, and some people can take years?
Well, I think what the average doctor who prescribes SSRIs thinks is based on the randomized controlled trials, which show that withdrawal problems are rare, benign, and quickly self-resolving. The problem with the trials is that the average person is on SSRIs for 5 years, and almost all of the trials are 12 weeks or shorter.
Yeah.
And there's one trial that there's only one placebo-controlled trial that is a year long, and there are no trials of them at all anywhere that are 5 years long. Now, if you look at the observational literature where people are surveyed about whether they have the withdrawal problems and how bad they were and how long they were on them, what that shows is that it looks a lot worse at 1 year than it does at 12 weeks from the trials. 2 years, if you've been on them for 2 years, getting off is a lot harder. And then if you've been on them for 5 years or 8 years or 11 years or 12 years, and it's catastrophically harder.
Yeah.
I don't know that we know that this isn't common among people who have been on them for 5 to 12 years. Because if you look at the people who have been on for at least 1 year, 38% of them tried to get off and went back on because they couldn't get off. And the other people are the ones with the withdrawal problems, right?
Yeah,
so
true.
I do think that the general description of this problem that conventional medicine sees is basically a scam, which is they know that their trials aren't long enough, but they like that. And, because it's like every time you test something for 12 weeks, this is true in nutrition as well. Studies of fish oil, for example, look, high dose fish oil looks great when you take it for 12 weeks. It doesn't look so hot when you take it for 4 years, 5 years, 6 years. And that's not to say that people shouldn't eat fish or shouldn't get omega-3 fatty acids. It's just to say that you can't generalize from a 12-week trial to a 5-year experience, And so I think this might be a lot more normal than we think it is. And I think a lot of people don't ever go off of them because of that. And then a lot of people who do just aren't taken seriously. Like when I started writing about this, then I got numerous comments from people who said, like my entire life was destroyed by this.
Yeah.
And, I lost my marriage, I lost my job, I lost everything. And no one believes me, So I think this is very common, but the principal problem I think is just being on them for a long time. But if we were to pray Father, forgive pharma because they know not what they do, it would be very, very literal in the sense that pharma doesn't know what their drugs do. And it's not really their fault that they don't know. It's that the human metabolism is way more complex than any of us understand. And so it always turns out that if you invent something that's never existed before, because you think it acts on one receptor to do one thing, it does a bunch of other stuff that you have no idea about, possibly as a primary mechanism. They call it off target, but what they mean is we didn't intend that.
Yeah.
And it's so I think pharma doesn't, but now they are to blame for, knowing that things are probably not so hot at 5 years of use than they are at 12 weeks and designing their trials to not know about those things. That's their fault. But it would be very, very hard for anyone to come up with a new drug and then with any reasonable time frame know everything that it does. Now, it turns out, though, that SSRI science basically destroyed the integrity of serotonin science. So the idea that serotonin is primarily acting in the brain, primarily acting on neurons, primarily to boost your mood and make you happy is total nonsense. And that is basically a marketing campaign that arose because of the SSRIs in the 80s. And the reality is that serotonin's primary role is to assist mitochondrial adaptations to absolute or relative deficits of oxygen.
Oh my gosh, that's completely different.
Yeah.
That's not the same thing at all.
Right. Okay. So if you inhale and you take a breath in, even if you were very good at breathing, not every segment of your lungs would be equally oxygenated. But most of us breathe like shit anyway, right? So we use a third of our lungs or whatever, right?
Yeah.
So you need some way to not send the blood that the heart is pumping to all of the lungs equally and to only go after the oxygenated parts. Serotonin is the traffic cop that sends the blood away from the poorly oxygenated parts to the oxygenated parts.
Okay. I didn't know it did that.
Okay. If you don't have now keep in mind, hypoxia doesn't mean that you're strangled. Like when you exercise, you now need more oxygen than you have, and that's why you start breathing harder. When you wake up in the morning, you now need more oxygen because your metabolic rate went down when you went to sleep. Your mitochondria took a nap. Now they're waking up with you, but they have to adjust. When you go outside and you get the morning sunlight, that signals serotonin to rise in your brain and create all those mitochondrial adaptations. Same thing when you're exercising. And in fact, serotonin is a major controller of the breathing rate. If you don't have enough oxygen in your bloodstream relative to your needs, serotonin gets released in your brainstem and makes you breathe more. So we completely misunderstand. We totally, or even in your gastrointestinal tract, 95% of your serotonin is in the gut, right? What is it doing there? It's not being made there to be sent to the brain. It's being made there to regulate the gastrointestinal motility. When you eat food, your gut uses up all its oxygen to digest that food. And if you don't push it along to the next segment, it's just sitting there. It's going to make that intestinal segment very hypoxic. It'll die, right? Serotonin acts as the thing that moves things along in the gut. Now, this is why 2 weeks of an SSRI causes nausea and vomiting, because your gut is overdosing on serotonin. This is why if you take an MAO inhibitor and you take an SSRI and you get serotonin syndrome as a result, it causes you to breathe too much, right? Because serotonin is a whole body chemical that is coordinating everything from your breath to inside the cell, mitochondria producing what they need to produce energy, the proteins that they need.
Wow.
All of that is regulated by serotonin. So I'll stop there, and I've been talking for a while, but that's pin one.
That's wild. So that explains, like, part of the reason, Dad went on SSRIs because he was crippled by depression. And it was also something that ran in my family, which I think has something to do with this B vitamin issue and who knows what. But like my grandpa was crippled by depression. My great grandpa was crippled and like disabled, not like, how people disabled depression, not like I'm sad, but like I can't move off the couch. And so Dad started them and they initially helped. And then when I was, I can't remember. I think I was 10 when I was on them, or 11 or something like that. But I remember the first time I took them, the first thing that happened was I was like, I can breathe. That was the first symptom.
Oh, wow.
It was, and Dad had the same thing. Instead of being like, I can't breathe, it was like, oh, my lungs are like working. And then slept for about a week and was like, oh, I can breathe.
That's really interesting.
And so it was such like a massive, I can breathe and relax type of reaction. Then it was like, well, these are life-saving and then life-ruining eventually. But that's interesting because this symptom of not being able to inhale was one of the main symptoms that kind of went along with the depression.
Yeah, I think someone coming from a conventional background would listen to that and they would say, "Oh, well, you had anxiety
and
that
you
was fixed
started
by
to
the
relax."
SSRI."
Yeah, but
people don't. Everyone always wants to pin anything that anyone on who's depressed, anxious, or is on SSRIs on psychological anxiety.
Yeah,
and they ignore the fact that the breathing rate is physiologically controlled.
Yes.
But worst of all, it's physiologically controlled in a way that you don't understand by the chemical that your drug is acting on, And
that's so bad.
This is so there is definitely a problem with SSRI withdrawal being underappreciated and under-researched, but that is not the primary problem why no one can solve this. The primary problem why no one can solve this is that no one understands serotonin and they don't understand SSRIs. And so one of the crazy things about what I just told you about serotonin and mitochondrial function is that part of what serotonin does to facilitate that is outside the cell. A lot of it is inside the cell. Serotonin, to do that, has to travel inside the cell, has to travel to the mitochondria and directly acts on mitochondrial receptors, then goes into the mitochondria and gets converted to melatonin, which has enormous benefits inside the mitochondria as well, all as part of this. So you take what they think, they named the SSRI after the fact that it prevents the reuptake by the neuron. So in their mind, all they're doing is just keeping serotonin in the synapse. But what they're really doing is they're blocking the transport of serotonin into the cell, in the brain, and in every tissue of the body, in every cell, in the placenta, in the gut, everywhere, right? And so SSRIs they're facilitating part of the serotonin mitochondrial adaptations, but they're preventing others. But then another thing people don't realize is that SSRIs also go into the cell. And then they act on receptors inside the cell that have nothing to do with serotonin, that are supposed to be activated in a cyclical stress response. And so SSRIs themselves will cause positive mitochondrial adaptations, but they'll do it in a way where you're supposed to cycle between stimulation and rest and recovery, and they just put pedal to the metal 24/7, 365. And so I think when people go off of these, they are developing new onset mitochondrial dysfunction as a result of their mitochondria becoming essentially addicted to this crazy mix of signaling that they're now just pounded with all the time. And with the clonazepam, so one thing is definitely true is that withdrawal from any benzodiazepine in neurons that respond to those benzodiazepines, and they're primarily acting on GABA receptors, which is the inhibitory rest and relax sort of neurotransmitter. It's definitely true that when you withdraw that, the neurons get overactivated, and the overactivation of a neuron beyond a certain threshold will cause mitochondrial toxicity, because you're basically throwing demand for mitochondrial metabolism through the roof, and the mitochondria can't keep up with that, and they're crushed by it. Now, clonazepam also, it's unclear how much it does this at the doses that people are taking, but one new piece of the puzzle with clonazepam is that clonazepam also goes into the mitochondria and basically switches it on.
That makes sense. Okay, so this is what happened with Dad.
Yeah.
We were still very depressed on the SSRIs. Like initially they fixed things, but for me, I got worse and worse and worse. And then when I started to fix my diet and I was on more of a paleo, heavy meat paleo diet, the depression lifted. I could just feel myself. I was like, oh my gosh, I'm never taking another medication again. Like that was my response. And I came off of them really quickly and then experienced SSRI withdrawal. Dad did the same thing. His SSRI withdrawal looked like mine, except it looked way worse. And then he went on Rogan and he was like, yeah, he gets made fun of for this. I had apple cider, which it had a sodium metabisulfite preservative that I don't know what happened when he took that, but I had a similar reaction. It was catastrophic. He didn't sleep for like 2 or 3 weeks and couldn't walk. He was green. He was like hunched over. Like it was catastrophic, but we knew going to a hospital, we didn't know what to do. And he eventually went to his family doctor who prescribed him clonazepam, and he took a low one clonazepam, and he slept through the night for the first time in 2 or 3 weeks, and went back to
this is so easy to
went
explain
back to work. And we were like, well, thank goodness. He was like hunched over, not able to walk, pale. He couldn't breathe. He kept being like, I can't breathe. Like horrible reaction. And then he took a clonazepam and like normalized.
Yeah.
And we know that was during antidepressant withdrawal, but like didn't know what to do at the time. He obviously had no idea how catastrophic it was going to be eventually, but was so sick, I think, we just didn't know what to do. So yeah, what's your comment on that?
Well,
does that seem like...
So clearly you and your dad both have a sulfur problem as a common thread.
And that was that was just before the meat diet.
Right. Well, I don't want to, what I said before wasn't to suggest that the meat diet is the primary reason you have a sulfur metabolism problem.
But it can tax the system.
I think sulfur metabolism problems are very common as secondary layers on top of any kind of mitochondrial dysfunction, because an energetic crisis leads to the cell saying, where can I get energy? It takes it from anywhere. And so it'll start breaking down sulfur amino acids. And as a result of that, if that pathway doesn't go to completion easily and smoothly, you get the production of something called S-sulfocysteine, which is a glutamate receptor activator. Okay. So you've got clonazepam is activating GABA, and S-sulfocysteine derived from the sulfite preservative in apple cider is stimulating glutamate. And so the fact that the clonazepam just shuts it off is, it just makes so much sense. It's, it's one lever, keeps you stimulated. The other one puts you to sleep. It's just two levers, right? And so it's idiosyncratic that the stimulatory lever would be, that a glass of apple cider is going to be the thing that's not normal.
No, it was messed up.
No, but it's completely possible, and it does fit in very well with the other stuff you've been talking about.
Wow.
But the high level summary is that SSRIs are mitochondrial drugs in ways that no one prescribing them understands. Benzodiazepines are mitochondrial drugs in ways that no one prescribing them understands. And you can get mitochondrial toxicity from the drugs, but what appears to be much more common is that people get new onset mitochondrial dysfunction after they stop the drugs. And I think that even though that's very common, the why exactly did it happen, and what exactly would you do about it to make it better, and what exactly would be the trigger to make it worse? Like, would it be the apple cider? I think those are very idiosyncratic. And part of the reason I say that is we've had a couple people who have used our test that had very bad, catastrophic, energetic failures after SSRI withdrawal. In one case, the guy was fully functional, but he developed all kinds of neuromuscular problems. He developed, urinary and electrolyte problems. He lost 17 pounds of muscle mass during this period. He couldn't travel. It was bad. The other one was in his 20s, in his early 20s, and he had chronic fatigue so bad he was basically bed rest for a year. He couldn't stand up in the shower because it took too much energy. There was a period for a month in there where he couldn't even get up to go to the bathroom, and he the kid's like 23, right? But their tests look totally different. And the second case I don't have data on yet, but the first case was a year ago, and I know exactly what made him better and exactly how he's doing now. And his results were phenomenal. So his results showed that he had, when we ran the test alongside his genome, we saw the exact reason for this, but his mitome testing showed that he couldn't transport methyl groups from the methylation process into his mitochondria. And one thing that people
have that.
Yeah.
That's what it feels like.
A lot of people that talk about methylation don't talk about how important it is to actually produce the engines in the mitochondria that make your energy, right? So it turned out with that test and his whole genome sequencing that he had a mutation that just blocked that transporter that's responsible for that process. So it makes a lot of sense. But anyway, his protocol was very methylation centric, but it was, it was a little bit kind of accelerated compared to what most people might do for methylation. But he had to microdose his way through it. So he took creatine, but he had to take 100 milligrams of creatine a day for a few months before he started working his way up in 100 milligram increments up to normal doses, like 1, 2, 3, 4, 5 grams. A lot of people are out there talking about 20 grams of creatine.
I've tried creatine and it doesn't make me feel good, but I'm taking
does it make you feel
the
bad?
scoop or something. Not like other things. It's not like agitation. Something doesn't feel good.
Yeah.
But not like B vitamins. But I'm taking like a scoop.
It would be interesting to microdose, but anyway, in his case, he wrote in at the 6-week mark, the 6-month mark, the 8.5-month mark, and the 1-year mark. By 6 weeks, he said he was feeling better than he had in years. By 6 to 8.5 months, he was saying like he had gotten his whole life back. At the 1 year mark, he had regained all 17 pounds of muscle that he had lost in that 1 year. And I was like, wow, that's incredible. But anyway, his results were stable over the course of a year. So I think that's really important.
Wow. And you could see, okay, let's just go back for a second to you talking about serotonin, how it moves in and out of the cell and everything. How do you know that? Like, how can you measure that? I didn't even know that was measurable because I know.
How is it known that serotonin goes into the cell?
Yeah.
Oh, well, you can look at it from a couple angles. There are different ways to measure whether something gets into a cell, but one way to do it would be to you can synthesize molecules and you can label them with isotopes where you can tell the difference between serotonin that you put on the outside of the cell and serotonin that the cell made itself. So that would be one way to see that, is that you see that the isotopically labeled serotonin makes its way into the cell. But when you're dealing with these kind of like biochemical pathways, there's never any one study that can illuminate the whole body of knowledge. You have to look at it from a bunch of different angles. And whenever you look at it from one angle, you're like losing perspective on another one. And so when all those angles start to agree with one another, that's when you really start to believe that you have the right picture. But, another thing you can do is just take isolated mitochondria and you can say, okay, what if we incubate them without serotonin or with serotonin? What does it do to the amount of melatonin inside? And if incubating them with serotonin makes the melatonin go through the roof, then and they don't get that melatonin when the serotonin's not there, that's another way to say, okay, once the serotonin's in the cell, one of its roles is to go in there, and then if you want to say it acts on one receptor to do one thing, what you do is you just find something that blocks the ability to activate that receptor. And, and this is getting into the weeds of like what molecular biologists do all day.
That was exactly what I wanted. It's like, okay, that was good. You know your stuff.
Yeah.
Sometimes I'll throw a question out there. I'll be like, well, but how do you know that for sure? It's like, well, and then things go a little sideways. That was really good. That was like, okay, that was impressive.
I can show you pictures of the stacks of the papers that I read with all the highlighting and notes all over them.
I can see that. That's wild to me. Okay, so that's all kind of like, bad news other than the testing and the case studies you said you have where people are getting better. But like, I'm going to use my dad as an example. I'm extremely functional. Now I'm kind of a bubble person and I'm very sensitive to things. But compared to how I was, like it's a completely different story. My dad he had periods of good time, but he gets hit so hard and he gets neurological. It looks like we know it's a neurological injury, and it's not a psych disorder. Last summer when he got sick, we were worried it was Parkinson's. We're like, what are these symptoms? But it's not Parkinson's. It's like a neurological injury. What do you do? Like, what should he do? Do the test, figure out which pathways are blocked and like slowly rebuild.
Yeah.
Use red light. Like, what do you do for these kind of things?
Well, first of all, the medical diagnosis is it's a model for understanding, like it's basically a model to predict whether someone is going to respond to the treatment that you are giving. And a lot of people lose sight that, whenever you have a model, there's a saying in statistics, all models are false and some are useful. And what that means is whenever you have a model, you are using a reality distortion filter, and I'm not saying that's a bad thing. You are making the data more useful, but to make it useful, you're ignoring a lot of stuff. And so when you get to this question of like, is it Parkinson's or not? There's a lot of things that cause things that look just like Parkinson's.
Yeah.
So now they've come up with the term Parkinsonism because you can say that this other disease causes Parkinsonism, but it's not Parkinson's.
Yeah.
And at some point you have to be like, if you look at the primary animal model to produce Parkinson's, they use the fish poison rotenone, which is a specific inhibitor of one of one specific mitochondrial engine that we test on our test, right? And so if you can just produce, like, are they producing Parkinson's or are they just producing Parkinsonism, and does it matter and should we care?
Yes.
I think the answer is it doesn't matter and we shouldn't care because neuromuscular dysfunction is a result of mitochondrial dysfunction because you cannot produce enough energy to control where the rest of your energy is going. And a lot of people don't realize that. Everyone realizes that to be energetic requires energy and to be active requires energy. But what people don't realize is that to rest requires energy and to sleep requires energy, because your body controlling that the energy is going into one place and not the other requires energy. It's just like, do all the Tesla batteries and gasoline get to the right places? Yes, with trucks that are burning gas to get them there, right?
Yeah.
And so if you think about some of the characteristics of Parkinsonism, you're talking about what is a tremor? It's you cannot control whether your hand is relaxed or doing something, and so it's in between.
Yeah.
And what is rigidity? It's you can't control when your muscle is flexed and when it's relaxed, and so it's something in between. And what is Parkinson patients often can't complete, like you want them to do this and they do something much weaker. And what that shows you is that they're contracting all the time when they don't need to, but when you really ask them to follow through with a really good controlled contraction, they can't do it. And so it's that the best way to see that is that you need the top 20% of your energy to really control where the bottom 80% goes. And when you lose that, especially when you lose it in the parts of the brain that are responsible for controlling movements, you get things like that. And I think that there is some value to trying to categorize it. But at the end of the day, what medical diagnosis really misses is, what if you have a copy and paste between half of two diseases? What you get is a rare undiagnosable disease. But if you left these boxes and you just looked at things as a continuum, you would say, okay, what's the underlying biochemistry and how do we fix it? And you cannot diagnose anyone with anything. And you can say, well, what's the underlying biochemistry and how do we fix it? And so we with Mitome, we operate outside of medical diagnosis, and we're just trying to help people understand their biochemistry to help them help themselves, because there's a time for a specialist and a diagnosis, and that's there, but we really don't have many people saying, I don't feel great, I don't know why, the doctor has nothing for me, what can I learn about myself so I can do better? And I think that's where we're trying to operate. But I think that there are certainly the time to do testing is when you've hit the wall of your knowledge, you're doing everything right according to what you believe is right, and now you need to learn something else. So I think that's where your dad is. Like you're extremely knowledgeable,
and then move forward.
He's very knowledgeable. You guys are doing your best. Now you need to get the missing pieces of information that you don't have, and so I think that's the case for him. But
I mean, I think you're spot on. Like the more I learned about even autoimmunity and mental illness and stuff like that, it was like, for some reason it's manifesting differently in different chronically ill people. But I think it could be basically treated the same way. Like we didn't have to split up. Like the hospital I went to as a kid, I was in the rheumatoid arthritis section, even though I had idiopathic arthritis. And right next to us was the lupus section. But if I had had a rash before I had arthritis, I would have been in the lupus section. And I was like, why are they, splitting up all this research into slightly different manifestations of autoimmunity when they all have so many similar symptoms too? So I think what you guys are doing is spot on. It's the treatment part that's tricky. Like once you figure out what's going wrong, what do you do? And do you suggest sauna and red light and nutrition?
Sure. So I think from a just what should everybody be doing kind of standpoint, I think the top 5 things that you really want to be thinking about for mitochondrial health are good nutrition, sunlight, exercise, your sleeping cycle. And I think that going through, I don't have an opinion on fasting to a great degree, but like specific fasting, but I do think making sure you're going through a robust fasting feeding cycle is an important part of allowing your mitochondria to regenerate. I think that the nutritional, now you asked about devices. So I think that most of these biohacking devices are replacements for a particular part of nature that we're missing. So morning sunlight is a great source of red light and near infrared light. And so you've got red light saunas, you've got near infrared saunas. I think that the point at which you want to start thinking about whether you should use a device is basically, do I seem to get more benefit from red light than I could get from the sun without getting burned? Mm-hmm. And, one angle to that is go out in the morning. Don't get all of your sun at 12 or 1 p.m. Get some of it for vitamin D. But, you're more in the morning sun. You can be outside for a couple hours and you're not going to get burned in most locations. But if you feel that your body is benefiting from a higher dose of that, then I think by all means, that's something you should try. I think that traditional saunas, I think, are beneficial. The research suggests that they're just generally beneficial for health. I think sweating out toxins is probably part of that. I also think that sauna is an effective way to lower your core body temperature. And a lot of people with genetic mutations have mutations that make the body temperature heat too hot for the enzymes. So I think there's an underappreciated explanation of how sauna is helping people cool their body off for most of the day in a way that combats a lot of negative effects of various genetic mutations. But I think those are all very good. And I do ultimately believe in the power of the individual person to judge empirically whether things are working for them. So I think those are all great things to try to address. And then ultimately, you don't want to be using any of them mindlessly. You want to be saying, okay, I have a strategy. Let me see how that's working for me. Whether you're going to use intuition or you're going to track things and use data, you got to use something to evaluate that for yourself.
Okay, that seems wise. What do you think? Okay, this is a random question. I've heard this being thrown around, and I'm not sure about peptides. Some of them I found very useful. Have you heard of SS31? Because everyone's been like, This is the mitochondrial peptide.
Yeah.
I've been like, that sounds a little scary, but.
So the largest study to date found that SS31 was not beneficial, and it doubled the risk of all of the side effects, including ones that were, probably biological in nature. People got more headaches, for example. It didn't look catastrophically bad, but it didn't look very good. They did do a subgroup analysis where they said, okay, what if we look for people who have mitochondrial DNA mutations? And it kind of looked like it might be beneficial for certain people, but the evidence-based medicine people would look at that and say, okay, now do a randomized controlled trial on those people. So I'm not against it, but it looks kind of iffy out on there.
Okay.
I would say on first principles, I'm disinclined to be excited until proven otherwise for something that is not inspired by nature. And I think this peptide, it's almost completely conceived in the imagination of a biochemist where they said, let's target an antioxidant to get to the mitochondria and do such and such. A lot of the peptides that seem to be more, at least work, are things that are inspired from nature where they said, okay, there's several mitochondrial peptides like MOTC and humanin that are produced naturally by the mitochondria in response to exercise. And I've talked to some friends who have seen a lot of people take them and who have said they think those things are primarily beneficial for people who are old and out of shape and who don't feel like they can get a good exercise program in. It seems to break a vicious cycle and allow them to kind of get that going. But I don't think someone who's in their 20s, 30s, 40s, 50s, who has the capability of of getting out there and getting at it should be taking exercise produced peptides instead of doing the exercise
Fair
that will
enough.
make their mitochondria make the peptides.
Okay.
Yeah.
That makes sense. My experience has been it's better not to screw around with. I don't know. I think from being on so many medications as a kid too and having such catastrophic like damage from SSRIs was like, I don't really trust anything.
Yeah.
Organs seem like a good idea.
It
Okay.
sounds like food has been a much better friend to you so far than...
You know what really helped me actually? Binders.
Yep.
Once I got sick from mold, I was on cholestyramine for a
Yeah.
while, and I still take that every now and then. And that really made a huge difference. But like that and meat.
Well, do you know what cholestyramine was originally used for?
Well, it's I don't know what it was originally used for.
Originally, it was a cholesterol lowering drug.
Yeah.
And it was what they used in 1984 for the clinical trial that was considered the proof that cholesterol causes heart disease. And it works by binding up the bile acids and causing their excretion.
Yeah.
But you make bile acids from cholesterol.
Yeah.
And when you get rid of the bile acids, your liver does not have enough cholesterol, so it takes it in from the blood.
Yeah.
It also increases its own synthesis of it. And a difference between taking cholestyramine and statins...
It increases its own synthesis of
Yeah,
cholesterol.
the liver says, I don't have enough cholesterol, so I'll make some, and I'll take some in from the
Cool.
blood.
Okay.
Okay, now, and I am familiar with Shoemaker's work. I had Shoemaker's books 20 years ago.
It's very niche of you.
I had made my own mold filter using a 25-inch box fan and a MERV 11 filter that I got at Home Depot.
When did
with
you do
packing
this?
tape. This was about 20 years ago, and it was
Wow.
in one of Shoemaker's books.
That's cool.
Yeah.
That's cool.
Before everyone had an air filter. But anyway, okay, so what's interesting about the cholestyramine as from another angle is that in the cholesterol synthesis pathway, you make two things that are essential to the mitochondria. One is coenzyme Q10, and the other is heme A, which is a component of the last and final engine in the mitochondria that makes the ATP. And so I think I totally buy the mold story, and I absolutely agree that cholestyramine is helping get rid of mycotoxins. But it's also interesting that it could have beneficial effects in the mitochondria that are independent of that. And the mold toxins are mitochondrial toxins. That's definitely good for your mitochondria.
That's for sure. So sorry, can you explain again? So how would creating no cholesterol and lowering cholesterol, so you basically recycle it faster? Does that just help with the creation of mitochondria?
The pathway to make cholesterol, it starts up here, and it's got like 30 or 40 things in it. And you got these arrows that go all over the place, making a bunch of stuff, and then cholesterol's right down here.
Okay.
So when people are modifying it with drugs, they're not acting down here. They're acting up here, and it's always impacting all the other stuff, right? So as you trace that pathway down, another end product is coenzyme Q10, and another end product is heme A.
Okay,
And those
okay.
are two components of the mitochondrial engines.
Wow.
So if you drop the amount of cholesterol, the liver says, oh, I need more cholesterol. What am I going to do? Well, one way is to turn up that pathway, and you get more of those downstream products. And another thing to do is to take cholesterol out of the blood. So if you are what they, in 1984, all they cared about was that it reduced the blood cholesterol because the liver would suck it out of the blood. Shoemaker is concerned with the fact that it's taking the bile acids, throwing them out in the feces, and with that comes the toxins carried in the bile. And I am adding an angle here, which is in the process of the liver saying, hey, I don't have enough cholesterol. Where am I going to get it? It doesn't just take it out of the blood. It also ramps up that pathway. And so one of the side benefits of that might be improving some of the mitochondrial machinery.
That's very interesting.
Yeah.
I wonder if that makes more sense. So when I started at the full dose, and I was walloped with all the like mold illness symptoms that I had, and I couldn't handle the dose of cholestyramine I was taking, so I had to go way down and start slowly. And the mold theory on that is, well, you're re-exposing yourself to all these toxins, so you can't go that fast. But does that theory make more sense? Could it have been
In terms of why you wouldn't have initially tolerated the dose of it?
Yeah, and like I tried to give, because dad was diagnosed with SIRS too, and every time he goes into a moldy building, like he gets hit. So, but he's so sensitive, he's like getting hit everywhere. But
I would think that in my mind, the most likely explanation for why you initially couldn't tolerate a high dose of it, but then you were able to work your way up, would be that the deficit in cholesterol itself was just flattening out the cellular function.
Interesting.
And because you can have many adaptations because there's dozens of things going on, but if the first thing you're going to do is to try to replace those bile acids by using up all the cholesterol the liver has before the liver is able to adapt to that, now just the cholesterol level in the liver is tanked. That cholesterol is a key component of cellular membranes all over the place, including in the mitochondria. So I could see that as just like you had to wait until you could ramp up those pathways to be able to handle that deficit of cholesterol. Like it had to be a gradual thing.
Do you think the reason that high performance people can get hit with these weird diseases that are like long COVID or Lyme, or it's like chronic illness and they don't know what's going on, could that possibly be stress-induced mitochondrial dysfunction? And so like burnout? Is that what that is? Because why are there so many celebrities that are flattened with like Lyme disease or mold or long COVID? Or is it because they're talking about them?
I think at a very high level, you have an energy budget and you need to manage that energy budget in a way that is responsible. And so I think one of the most interesting things about mitochondrial function is that in general, it declines 1% per year with age.
Oh my gosh.
And so I think that the major driver of aging is that loss of mitochondrial function. But now you can say, well, why is it declining? And I actually think it's its own explanation. And what it is the mitochondria produce the energy that is needed to fuel the production of everything in your body, the maintenance of it, the repair of it, and the distribution of it. That includes the production of everything in the mitochondria and the maintenance and repair and distribution of everything in the mitochondria. So the mitochondria need to fuel their own cleanup and their own maintenance. And so if the mitochondria create a given budget, and then you have things that detract from that budget, you will need a period of rest and recovery to recuperate that and get the budget back on balance so you don't wind up bankrupt, right? And so if you're hit by COVID, or you're hit by Lyme disease, or you're hit by volleyball hand injuries, or you're hit by a skateboarding accidents, or you're hit by traumatic events or whatever, it doesn't matter what those are taking energy out of that budget. And I think the normal thing that happens with age is the mitochondria just didn't get 1% of what they were missing 1% of what they needed for their total maintenance that day. And so now maybe their function is down 0.01% as a result of that. And maybe if we knew everything, or if we had the willpower to do it, to rest and recover properly from everything, we could prevent that from going into a vicious cycle. But what happens is with aging, with all those insults, that becomes a natural self-fulfilling vicious cycle. And so if you are a person that cannot let go when you need the rest, I do think that works against you from that perspective, because those insults are much more likely to lead to a deficit that never gets made back up in the mitochondria's ability to repair itself. And that can push you much earlier into a vicious cycle than you would otherwise be pushed into.
Okay. I mean, that makes sense. Well, I think that covered most things. I'll definitely be ordering your test. It's mitome.com, right?
Yeah. Mito.me.
Mito.me.
Yeah.
Okay. And I'll link that below for everybody watching. But fascinating. Absolutely fascinating. So thank you very much for coming on.
Thank you for having me.
And where can people find you online if they want to learn more?
chrismasterjohnphd.substack.com is my newsletter. Mito.me is the mitochondrial testing. And then you can find me on pretty much any platform.
Cool. Well, thank you again for coming on the podcast.
Thank you so much for having me.